Good afternoon, Wolfpack, and welcome back to our lesson. We are on 2.2 reflections. Our essential question is, what are translations, rotations, and reflections, and do they preserve angles and distance? Don't forget, reflection is a type of transformation, and it is specifically a transformation in which each point of the original figure, called the pre-image, has an image that is the same distance from the line of reflection as the original point, but it is on the opposite side of the line. You probably learned back in elementary school that a reflection is called a flip. Okay? A reflection is a flip. Reflections preserve size and shape, so they are rigid motions. They do not get bigger, they do not get smaller, they are rigid. Just like a table is rigid. It cannot really change its shape or size. So those are reflections. Rules for reflections on a coordinate plane. The reflection across the x-axis, so our original point is xy. The reflection across the x-axis is x, comma, negative y. X stays the same and y gets a new sign. And here's an example. If I have this point right here, a reflection across the x-axis means it's going to come down here. Okay? So reflected down to here. So it stayed in the exact same spot on the x-axis, but it changed on the y-axis. Okay, let me maybe make it a little bit bigger. I have this point here, and I wanted to reflect across the x-axis. Here's my x, here's my y. It's still in the same location for the x-axis, but while it was up here for the y-axis, it's now down here on the y-axis. A reflection across the y-axis, starting points are x, y. Our new points are negative x, y. So since we're reflecting across the y-axis, y is going to stay the same now. And so let's take the same point. We're going to reflect across the y-axis. It's now in the same location, the y-axis, but as you can see, whereas it was in the positive x, now it's in the negative x. Okay? So then we have the rule reflection across the line y equals x. And oh, I did it again. Sorry, guys. The xy simply trade places, become yx. No new signs, nothing like that. They just switch places. An example of that would just be, here's, this would be a line y equals x, where it's just kind of flipping over that line. If it's here, now it's here. If it's here, now it's here, and so on. It's just reflecting across the line. Okay. And then the last one is reflecting across the line y equals negative x. xy becomes negative y, negative x. So they trade places, and they both get a new sign. Now, I want you to pay close attention to this. This negative sign does not mean that the coordinates are now negative. It means that it gets a new sign. So if it was positive, it's now negative, and if it was negative, it's now positive. Oh, and I apologize. The line of reflection y equals negative x, that would just be the opposite way. Okay, there's your y equals negative x. So there are your four types of reflections. So we're going to draw the image of triangle RST after a reflection across the y-axis. Now, if you have a picture, there's no need to write down all the coordinates. If you want to, you can. You can write down R, S, and T, and then say, okay, R is at negative 1, negative 2, negative 3, negative 4. R is at negative 4, 3, and so on, and apply the coordinate notation. But if you have a picture, just use the picture. So start off with S. S is one coordinate away, 1 point away from Y, which is the line of reflection. And we are reflecting across the Y-axis. So since it's one point to the left, there's my new S, S prime. R is 1, 2, 3, 4 away from the line of reflection. So 1, 2, 3, 4. Here is R prime. Let me erase these little, you don't get confused. T is 1, 2, 3, 4 away from the line of reflection. So I'm going to count, and here is T prime. And then you draw your triangle. You have R prime, S prime, T prime. So you could have applied the coordinate notation, or you can simply use the picture to help you with this line of reflection, okay? So I'm not even going to go through doing all the coordinate notation because there's honestly no need to since we have a picture. We'll get to that. So example number 2. Draw the image of triangle JKL after reflection across the x-axis. So this time we're going to reflect across the x-axis. That means J and K are going to be below the x-axis, and L is going to be above the x-axis. So J is 2 above the x-axis, so now it's going to be 2 below the x-axis. It's staying in the exact same spot on the x-axis at -1, but now it has a new y-coordinate. So here's J prime. K is 2 above the axis, so it's also going to come 2 below the x-axis. So here's K prime. And L is 4 below the x-axis, so L is now 4 above the x-axis. And then you connect your points, and there is your new shape. Okay? If you have any questions, make sure you're writing them down as we're doing this, and so that way you can ask in class. So now we're going to reflect the figure with the given vertices across x equals 2. We're going to draw the pre-image and the image in the graph provided. So we are going to need to do coordinate notation at this point. So the first thing you're going to do is draw your line of reflection, and that's x equals 2. So x equals 2 is right here, and here's my line of reflection. So I'm going to reflect it across that line. So my original point, D, is at -2, 1. E is at -1, 4. And F is at 1, -3. And I'm going to connect my points. I'm going to label them so I don't get confused. D, E, and F. Okay? So there's my starting figure, if you will. Now I have to flip it over the line of reflection. So the first thing you have to do is figure out how far away it is from the line of reflection. So you're going to start with our point D. D is at -2. And let's use red. So D is at -2. It is 1, 2, 3, 4 away from the line of reflection. So I have to go 4 more. 1, 2, 3, 4 for my new point, since I am reflecting across x equals 2. So here is my D prime. Okay? And if you think about it, it had to travel 4. It had to go from -2 all the way to 2. Okay? So from -2 to 2, that's 4 spaces. That's 4 spaces there. And then I have to go 4 more the opposite way, the other way, or I should say in that same direction, across the line. So 4 times 2 is 8. Okay? So I'm going to take 8 and I'm going to add it to my x coordinate. -2 plus 8 is 6. So D prime is 6. And remember, the y stays the same. It's the same exact spot on the y-axis. Okay? Do the same thing with E. E is 1, 2, 3 away from the line of reflection. So we're going to go 3 more. 1, 2, 3. There is my new E prime. Okay? And it's at 5, 4. So E prime is at 5, 4. 4. Well, let's use that same logic we just used. E started at -1, and it needed to go 3 spots to the line of reflection. So -1 had to go to the line of reflection was at 2. That was 3 spots. Well, then we have to go 3 more spots to our final point. So 3 times 2 is 6. I'm going to add 6 to -1, and sure enough, -1 plus 6 is 5. So you can do this mathematically, or you can use a picture. We have the picture, so I'm doing the picture first, but then I'm also showing you to you mathematically. So let's do F. F is 1 point away from the line of reflection, so I go 1 point on the other side, which is right here. And that's F prime. I connect my points. Okay, so there's my new figure. Now again, F was at 3. Sorry, F was not at 3. F was at 1, and it had to go 2, 2. So it went 1 spot, 1 point. Has to go 1 more point the other way, so 1 times 2 is 2. I'm going to add 2 to my starting point. 1 plus 2 is 3. So my x-coordinate is at 3, and my y-coordinates stay the same. And sure enough, my x-coordinate is at 3, my y-coordinates stay the same. So these are your coordinates. D prime, E prime, and I did not write F prime. If you have a picture, you can just count. I know that you guys can say, oh, well, E to the line of reflection is 1, 2, 3, so I'm going to go 3 more. 1, 2, 3, here it is. You can count. That's totally fine. But knowing how to find it mathematically is just as important. How far did you travel to the line of reflection? I traveled 3. Well, you have to double that distance because you have to keep going. So 3 times 2 is 6. And then you add that 6 to your starting coordinate. Okay? So we said -1 plus that 6 was 5, and that's what we got. So if you have a picture, use it. If you don't have a picture, that's why you have to know how to do it mathematically as well. And again, guys, if you have any questions at all while we're doing this, you should be taking notes and writing them down so that way we can go over them in class. One more. Example number 4. Given are the coordinates of triangle NAP. What are the coordinates of the image after reflection across y equals x? So after the reflection y equals x, my points start off x, y. If you look back at the front of your page, when I'm reflecting across the line y equals x, that simply means that I'm going to write the coordinates in that form, y, x. So they're just switching places. So n prime becomes 2, 4. No signs are changed, just the order. A prime is 1, 2. And P prime is -3, 5. These are my new coordinates. Okay, 2 is still in the x location, so I would still graph this 2 on the x-axis, 4 on the y-axis, okay? This spot is always the x spot, and this spot is always the y spot. Oh, not me about to be yellow. Okay, this is still x, this is still y. So if I'm graphing this point, the point 2, 4, I'm just going to sketch it out for you. 1, 2, 1, 2, 3, 4. This point is still here, 2, 4. I just found what the points were by applying that reflection rule. And the reflection rule says take your original points and switch location. So whatever x was, it's now the y. And whatever y was, it's now the x. Okay, just switching them around. These coordinate rules from the beginning, you are going to have to know those. Those are not supplied to you. And if you do not know those, you're going to always wonder, like, what in the world we are doing. So these reflection rules, you need to make sure that you are studying these rules because you will need them time and time and time and time and time again. Okay? If we're reflecting across the x-axis, x stays the same, y gets a new sign. If we're reflecting across the y-axis, it's y. So y gets to stay the same and x gets the new sign. Reflecting across the line y equals x is in that order, y, x. And reflecting across the line y equals -x is in that order, and they both get a new sign. Please make sure all of this is complete. We will finish the rest of this in class. Have a great day, Wolfpack, and I will see you next class period.